Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with spectroscopy for chemistry, and this is lecture number 6. In this lecture I will explain you a little bit about infrared spectra. In previous lecture I told you about microwave spectra in brief, not in detail, because microwave spectra is studied in a different way, but that I'll take later on. Even infrared spectra is also studied in a very much detail, but that will be later on. I'm giving you just a brief introduction to different kind of spectra, and this is for infrared spectra. So let us see what is infrared spectra and what will you see in this case. So infrared, this is basically light, and light is wave as well as particle. So if we consider wave nature of light, then it has definite wavelength as well as frequency. Okay. So what is frequency? Frequency is equal to c upon lambda. C is velocity of light. The unit of frequency is hertz or second inverse or cycles per second, CPS also. Okay. So in this case we see C. What is C? C is velocity of light, and this is constant, you know that. Okay. Here for infrared spectra we use another unit, and that is wave number, that is frequency bar. It is known as wave number, and it is different from frequency. So wave number frequency bar is equal to 1 upon lambda. Here there is no C in this case, and the unit is centimeter inverse. Okay. So infrared, which is important for us, having wavelength nearly 50 micrometer. And if we see the range of infrared in which we would observed spectra is having unit wave number, and that is 4000 centimeter inverse to 500 centimeter inverse. So this range is important for us. Okay. Now I will show you that energy of infrared, which is known as E vibrations, because it will bring change in vibrations of molecule, okay, is always greater than energy of microwave. And as microwave produce change in rotation, so it is called E rotations. Okay. And energy of infrared, that is E vibration, is less than energy of UV visible light. Which will to produce a change in translational motion. So electronic translational motions is written as like this. Okay. So E vibrational will be less than E electronic motions, and E vibrations will be greater than E rotations. Okay. When a polar molecule, you must be knowing what is polar molecule, which has polar bond, at least one polar bond. Examples are H2O, CHCl3, chloroform, CH3CN, acetonitrile, etc. Any other example can be taken, in which you will find polar bond as well as molecule itself is a polar. Sometimes molecule may be non-polar, but it has polar bond. It also happen like CCl4. Okay, so this molecule which has polar bond absorb infrared, then atoms within molecule start vibrating. The change in vibrations may change bond length and or bond angle, which can be recorded. Okay, so this way, when molecule absorb infrared, you will find change in vibrations. Okay, and that can be recorded because it is basically giving change in bond angle as well as bond length. So the energy required for changing vibrations is known as vibrational energy, E vibrational. So vibrational energy, which is always greater than rotational energy, and this is obtained by microwave. So here, thus, microwave can change only rotational levels of molecule, but not vibrational levels. But while infrared can change because it has more energy than microwave, so it can change vibrational levels as well as rotational levels of molecule. These changes produce lines. Okay, these changes produce line. Not only due to rotations, change in rotations, but also produce lines due to change in vibrations. That means when molecule absorb only microwaves, you will find only change in rotations. But when molecule absorb infrared, molecules start rotating as well as vibrating. So due to infrared absorption, molecules shows rotations and vibrations, both. Okay. Therefore, when molecule absorb infrared, we get bunch of lines which merge with each other because they are very close and give and produce a band instead of lines. Okay. So it's like this. There are so many lines which are very close to each other. It's very difficult to, split them. So instead of lines, we will observe this kind of band. This is bunch of lines, or we call it band. And this band is appear in infrared spectra. So the series of bands appear on a recorder in the range of 4000 centimeter inverse to 500 centimeter inverse is known as vibrational rotational spectra, or IR spectra, What kind of information is obtained from IR spectra? Very important information is obtained from IR spectra, and that is about different types of bonds. Here, different types of bonds between different atoms is observed in all organic molecules, and that we can find out with the help of infrared spectra. That means we come to know different types of functional group present in organic compound with the help of infrared spectra. So this is very important spectra for us, but in detail in some times, not now. Thank you so much.